I am Krishna Rao Patro, Associate Professor in the Department of CSC from IARE College, Hyderabad. So today we'll discuss about one problem: how to merge two sorted linked list. So in the previous session you have seen how to create the linked list and how to traverse the list and how to reverse the list. Those things you have seen. Today we'll see one more important program, that is how to merge two sorted list. So that means what? You have to create two lists. And while creating list, you have to give the data in a sorted order. That is the given condition. And after creating two lists, then you have to merge into a single list. Now here if you observe here, there are two lists, list 1 and list 2. List 1 contains 5 elements, list 2 also contains 5 elements. Those elements are first list having 10, 20, 30, 40 and 50. Okay. And second list contain 5, 15, 18, 35 and 60. That means if you observe here, both the list having sorted order data. So finally, after merging these two, and this merged list also again sorted order. So you have to merge in such a way that the merged list also should in a order, sorted order. So while merging, what you have to do? You have to check which data is smaller one. Whichever data is smaller one, that you have to keep first. Now if you observe here, in the first list, the first value is 10. In the second list, first value is 5. So that means 5 is smaller than 10. So in the merged list, 5 should come first. After merging, then I should go to second node. My second node is 15. But still the first node of the first list is 10. So now you have to compare these two. Whichever is small, that you have to keep first. So 10 is small. So 10 should come to the next. Then next you should go to next data. Next data is how much? 20. Again you have to compare. That means here the pointer is moving to 20. Now you have to compare the 15 with the 20. Whichever is small you have to keep first. So 15 is small. So after keeping 15 here, then this pointers move forward. So like this you have to keep on going till end, until you reach end of the list. If one of the list is already reached end, then remaining you can merge directly. Okay. So if you observe the final list, 5, 10, 15, then 18, then 20, then 30, then 35, and then 40, and then 50, and then 60, and at the end you reach null. So that means your ultimate goal is check the value of the list, means value of the every node. Whichever value is small, that you have to keep first. So this is the list 1, this is the list 2, this is finally the merged list. So you should create how many lists? Initially you would create 3 lists. Okay. Sorry, you have to create 2 lists. And the resultant list should be available in another list, merged list. So this list consists of 5 nodes. Second list also consists of 5 nodes. And finally the merged list consists of 10 nodes. So while merging, these 10 nodes should come in a order. That is the main goal in this program. Okay, like this you have to do. Now, how to create this first? The first goal is how to create it. So you can create this one using any other programming language. So let us choose our Python programming language. Now I'll explain the program how to do. Then we'll do the program. Now please observe here. 1, 3, 7, 9, 8. This is my list 1. Similarly, 2, 4, 5, 8, 10. This is my list 2. Now if you observe here, first list is in sorted order. Second list also in a sorted order. So after sorting, then I will be getting my merge list. The merge list consists of what? Both the items of means both the list items. Whichever item is small first and then next. So if you merge these two, so what you will get? First one will get yes, then 2, then 3, then 4, then 5, after 5, then 7, then 8, then 9, then 10, and then 11. So after 11 there is no list. So this is my final merge list. So this is your target. So first of all you have to create a node. So in every node we will have two parts. What is the two part? First is data part, second is the link part, because the link part will be holding the address of the next node. So create a class. The class will be holding two items. One is the data part, second is the link part. Link part means which will be holding the address of next node. And this node you have to create dynamically as and when you need. So you have to create a separate class called node. After creating the class node, then that node you can use for your linked list. Now you can design a class like this, class node, and whenever you are creating, this object should create. I think you know in Python there is a constructor method. So the constructor is written with the help of the method called init method. So this is a built-in method. So whenever you are creating a node object, automatically init method will be called. This method takes the parameter called data, because this is the main one. And the next part, that the address you are not storing here, because address you cannot generate, that system will generate. But you should have a variable called next. The next is a pointer which is pointing to next node. So whatever the data you are passing, the data you have to store in your node. This is my node, this is my data part, this is my next part. Whatever data I am passing, the data will be stored in the data part. And the next part, initially you do not know, so put a none. So when you create a node, this type of node will be created in the memory. So generally this data will be passed during runtime, and the node will be created in the heap area. Remember, there is a separate area called heap segment in the memory. In the RAM there is a heap segment. So the linked list generally uses heap segment to create the node. Then you can write a linked list program. There initially you maintain a head pointer, but start pointer initially it is none, because the none indicates nothing is there. Then you write a method called print method. The print method will be allowing you to display all the data till end. So this portion which is displaying the linked list information, and this is a special method which allows you to append or push or insert some data, because whenever you want to create a new node for the list and you want to attach, so you can call this append method. So this append method can be called to attach the list, because you are creating a data. Here you are calling the node. This node is what? Built-in class, not built-in class, that is user-defined class. So whatever data you are passing, that data is stored in the node. This new node you have to attach to the list. If head is none, that is the first node. If head is not none, that means some nodes are already available. Then initially your last node is also head node. The second time onwards, the last of next will be holding last equal last of next, keep on going till last next equal to new node. So this is the way you are appending at the end. Similarly, this is the main part, merging. Initially you can check while merging whether first list is empty or not. If first list is empty, that means you are merging two lists, but first is nothing is there, first is none, but second having some data. Assume some data 10, 20, 30. So my first list is H1, second list is H2. When nothing is there in the first list, then my merge list is also same 10, 20 as well as 30. So this is the way I will get. So similarly in the second case also, if head 2 is none, I will return the directly head 1 itself. So you have to check whether list is empty or not. If first list is empty, you return the directly second list itself. If second list is empty, you return first list itself. Because if one of the list is empty, nothing to merge. So simply you can return. If both lists are not none, that means not empty. In that case, you have to check one by one. If first node's data is less than second node data, that means I have to make the first node data as a first node. So I'll make temp equal to head 1 and temp of next. The first node's next will be merging with second. So I will be calling my merge list function, recursive function. So while calling, what I have to call, because first node's data is already available, so I should go to next. How to go to next? So head 1 dot next. Why I am going to head 1 next? Because head 1 data is less. So I have to go to second member of the head 1. If head 1 is not less, then in that case else, then I have to go to head 2. So in head 2, temp of next equal to merge head 1 with head 2 of next. So it is keep on going until merging. At the end, return the temp, because temp is holding my starting address. This address, once it comes, then you can display. So initially, my linked list is created with 5 nodes, 10, 20, 30, 40, 50. So the list 1 is created. Initially, linked list object is created. Second linked list is created, because your goal is create 2 lists. So first list and second list is created with different values. But you must be very careful while giving the data. Data must be in a sorted order, because our goal is merging to sorted list. So here you are not checking whether your list 1 data is sorted or not. So you are responsible now to give the data in a sorted order for both the list. After list is created, then you can call list 3 equal to linked list. Then merge list. Initially the list 3 is empty. Then your head 1 and head 2, you are passing starting address, because head 1 is always holding the starting address of list. So I am passing list 1 set as well as list 2 set. You pass these two as a parameter to this method, and finally after merging, it will return the starting address, that is goes to head, and after that you display it, because finally you have to display the output. So this is the final goal. Now let us do through our special editor. This, now you have observed the program. Similarly, now I want to run same program through my idle editor. So after that, I should get this address, means this value. This is the final output of the program. Let us have a small program. Yeah. Now please observe here, I have opened my idle editor through which I will develop my program. So I will go to my new file. There I can type my program. First of all, what I have to do, because the first goal is create a class node fine. There my goal is to initialize my object. So for that you have to call init method. So write def underscore init underscore followed by, because this is my member method or it is my built-in method, the first parameter is always self, because in Python for every member of the class you have to make the self keyword as the first item, comma, whatever the data you are passing, this data you are passing dynamically, and at the end you have to give the colon, and here you have to assign the value. So my self dot data equal to data, and remember the name can be same or maybe different also. If at all you want to write dat, that is also no problem. So this is my parameter, but this data you cannot change. This is my member variable, this is my parameter variable. Okay, and because I told you in a node you should have two things, data path as well as link path for next path. So self dot next equal to none. So in Python you should write none keyword to represent as a null. So my class node is ready. Now this node I have to use in my linked list while creating the list. So now I will create another class called linked list. Here I will write my first constructor, because in my linked list I have to maintain one starting pointer by head pointer or start pointer. That start pointer will be holding the starting address, or I can say head pointer. Head pointer will be holding starting address. So I have to initialize. So to initialize, I have to write my constructor. So for that, underscore init underscore bracket. Here I told you this is my member method. Of course, it is a standard keyword also. I have to use the standard keyword called self, comma. Initially, you are passing nothing, because while creating object means linked list object, nothing I am passing. So here I have to maintain a pointer called head pointer. So self dot head equal to initial head is pointing where? It is pointing to nowhere. That means list is empty. So I will write here none. So my linked list object is ready. There my head pointer is none. So here I have to decide what method I should write. One is push or append. Second is display. So first of all I have to create the list. So for creating I have to push the data or append the data. So I will write a method called def append, or I can say insert. That also possible. Append means generally we are appending at the end. That is nothing but insert at the end. So you can write this also or that also, no problem. And you want to make this as a member method. So how to make this as a member method? You should write the keyword called self, comma, and you have to attach the new data. So I will pass the new data. This new data you have to pass through this method, and for that data you have to create a object. So what object you have to create? You have to create a node object. So create a node object. So I will create a new node equal to, how to create new node? Because already I told you there is a class called node class. This node class you have to call here. So node, my node takes how many parameter? And the data. So whatever the data I am passing, so here I am passing new data. Please observe here I wrote new data, whereas here I wrote date. Is it okay? Yes, no problem. There is no, because this is pass by value. This is my actual parameter. This is my formal parameter. You can write anything. But for your clarity, you can write DATA. There is no problem at all. But both are correct. So when I am passing this new data, automatically this data goes here and one node is created. Now this new node you have to attach. Where you have to attach? You have to attach at the end of the list. But initially, whether the linked list having some data or not, some node or not, I have to check. So how will I know? For that, there is a starting pointer called head pointer. This head pointer knows whether any data available in the list or not. If head is none, it says nothing is there. It is empty. If head is not none, it says some data is already available. So here you can put a condition whether head is none or not. So now I can put a condition if self dot head is none. If it is none, then it says it is empty. If self dot head is none, it is empty. So now here what I will do, whenever it is empty, here I can now write self dot my head pointer equal to my new node. So new node become the first node. This is the starting node, because always the first node is the starting node. So I am making this new node as a first node by assigning to the head. Otherwise, if head is not none, then I can go to else. So in else part, what I will do, I can go to till end and attach. Otherwise, there is also simple way you can assign the starting address as well as every node's address to a last node also. So that way you can do, or otherwise you can go to till end and do. So let me go to end. I'll assign one temporary pointer, temp equal to self dot head. Okay, I got the starting address. So whenever the second node comes, I have to go to till end of the list and attach. So how to go to end? I can put a condition while temp dot next, while temp dot next is, if temp dot next is not none, then I can continue. So I can put a condition whether it is true or not. If temp dot next is true, then I will go to next, temp equal to temp of next. So that means what? The loop is keep on running whether next node available or not. If next node is still available, go next. If next node is not there, then stop it. So when the loop is over, it indicates you have reached end of the list. So there I will let us temp dot next equal to my new node. So new node will be attached at the end. That means you are appending. You are appending. So this way my list is ready. That means appending is over. Finally, after appending, you may interested to display all the node. So for that you should write a print method, print list. Now you want to make print list is also member method of the class. So you should write self keyword. Now here what I have to do? My method I have to display it. So initially I will take a temporary pointer, temp equal to self dot head, because whenever you want to display any data, you have to take the starting address. So the starting address is available in the head pointer. So I am assigning here. Then I should continue till end while temp. That means until I reach end, I have to continue. So here what I have to do? Print temp dot data, and at the end I should give one arrow mark symbol. So I am putting an arrow symbol because in a linked list generally after displaying every node you have to give arrow symbol. That is general representation of the linked list. So I am putting here. Now after displaying the first data, I have to move forward. How to move forward? Temp equal to temp dot next, because the next pointer knows the address of the next node. So continue till end. When you reach end, then will come out. Now generally in the linked list at the end you have to display a null symbol. So here what I will do, instead of displaying the temp of data, here directly I will display the cross mark symbol. Generally that is the representation of end of the list. So this way I am displaying. So here now what happened? My linked list creation is ready. Now here I should write my driver program. Till now my class is ready. Linked list class is ready. So here I will create the object linked list. My head 1 or list 1. So here I will create my object, Control X, list 1 equal to linked list. That means what? My constructor is called. List 1 is ready. Once the list 1 is ready, then I have to append the value. So list 1 dot append how much? Some value you have to start. Let me start with 10. So that means first 10 is appended. Next I am appending 20. 20 is appended. Next I am appending 30. Okay, 30 is appended. Okay, now here how many are there? 3. Let me display first whether it is displaying or not. List 1 dot, for displaying I should call which method? Because already I wrote print list. So here I can call print list. So let me display first. Control S, my merge list dot Python. Automatically Python will be coming. Fine. Now I want to run. Press F5. Yeah. 10, 20, 30. List is created and display. So first list is ready. Because our goal is what? Merging two sorted list. Now I have created only single list with 3 data. Now what I will do? I will go to second one. My first list is ready. In a similar way, I will create second list. Control C, Control V. So here what I will do, instead of list 1, I will say list 2. List 2 is ready. This list 2 is what? Head 2, second list. But here the values will be different. Here I will make 5, 15, 18, 35. Let me write 35. 35. Now here what happened? List 2. So here I should write list 2 dot append. If I write list 1 dot append, it goes to first list. So here I am writing list 2 dot append. So my second list also ready. After displaying, now let me display second list also. Control S, press F5. Yeah, first list is ready as well as second list also ready. Now our goal is what? Merging two list. So I have to write a separate method for merging. Merging is now that is not part of the class. I will write a separate method which will take the two lists as a parameter, and by taking these two I have to merge it. Now let me write a separate method called merging. So up to this my list class is ready. Already initially what you created? You created a class called node. Second you created a linked list. Then I will write a separate method which is not part of the class. So I am writing outside the class. I will write a method called merge. So whenever you want to write your own method, write a keyword called def, and I will write here merge list. Merge list. This is not a member method of the class. So I will not write self. If it is a member method of the class, then I will write self. Here it is not a member. That's why I will not write self. But here what I have to do, I have to pass two parameters. I will pass the head 1, comma, head 2. I am passing these two arguments. Here my goal is merging. Okay. Now, first of all, I have to check whether head 1 is null or not. Because sometimes without creating I may pass. So in that case head 1 may be null. Or sometimes head 2 I may not create. In that case head 2 will be null. Because simply creating means it will be null. Okay. So now here first to my goal is check whether there is any data available or not. So I will make one temporary pointer because here I have to merge. Initially temp is none because here I will be attaching these two and storing. And here I will check if head 1 is none. If head 1 is none, that means what? What I have to do? Because head 1 is nothing is there. So finally I should return head 2 because head 2 is having some data. Similarly, I may check whether head 2 is none or not. If same thing, I will put a one more condition. If head 2 is none, then I will return head 1 because head 1 having some data but head 2 having nothing. So I will return head 1's information. Otherwise, if head 1 having some data, head 2 also having some data, in that case, then I have to compare the value of both the list. So take the first data of the first list and take the first data of second list, then compare. Then here I will put a condition. If head 1 dot data part, we have to compare with the data. Head 1 is less than head 2 dot data. If this condition true, so what I have to do? I have to merge this. So I have to start the temp will be starting address head 1, because head 1's data I have to compare. So now my temp of next will be merged with remaining part. So I have to keep on merging. So I'll call recursive way merge list with what? I have to go to second member of the head 1. So here I'll write head 1 dot next. But head 2 is not moved because head 2 is still greater. So here I'll write head 2. Head 2. Else, if head 1 is not less than head 2, in that case it go to else part. That indicates what? Head 2 is bigger. So in that case I'll write here temp equal to my head 2. Instead of head 1 I'll go for head 2. Then temp of next equal to, I will call my merge list of head 1, because my first parameter is always head 1, but head 2's next. Head 2 dot next. Keep on calling, and at the end I will return the, because finally the address will be available in the temp. Starting address of the merge list is available in the temp. This temp is returned from the merge list function. This I have to store here. What I have to do? First of all, I have to create a list 3, means head 3, merge head 3 equal to linked list. Now nothing is there. Sorry, don't put semicolon, because it is not C or C++. In C, C++ you have to give semicolon, but in Python don't give any semicolon. Okay, print list. My linked list is ready. Head 3 having nothing is there. Now what I'll do? Head 3 equal to, I will call my merge list. In merge list, what I will do? I will pass my first list as well as second list. So after passing first list and second list, then I will get here head 1, comma head 2. So head 1 as well as head 2 we are passing as a parameter. After merging, I have to display whether it is coming properly or not. So head 3 dot print list. Now let us check. Control S F5. What is saying? There is some mistake. Line number 53. Head 3 merge list head 1, comma head 2. Head 1 is not defined. Let us check what is the mistake. Sorry. List 1. Don't write head 1. I will write here list 1. So here also I will pass here list 1 is my linked list, because starting address. This is my list 2. And for the namesake I will write list 3. List 3 is my merge list. Okay. So the name you can write anything. Control list 3 and list 3 dot print list. So now my naming conventions are okay. Control S F5. Still there is in head 1 dot data line of list merge list 1, comma list 2, line number 30. You are having some errors. Head 1 dot data is less than head 2 dot data. Object has no attribute data. The attribute error head 1 and head 2 data is not the same. Let us check what is the mistake. If head 1 dot data, we are passing head 1 as a parameter, merg merge list head 1 next and head 2, head da merge list we are passing head 1 and we are passing head 2. If head 1 is none, then here passing linked list. List 1 is your first list, list 2 is second list. So when you are merge, say merg, merge list, merge list, it's fine, but still it is showing why. Head1 dot data is less than head2 dot data, then temp dot spelling mistakes, anything HEAD head1, temp dot next, this is my next DA. You have to pass the head parameter, yes, because here linked list having no parameter, fine. Here the list is the starting, but you have to pass the head pointer. So list1 dot head. Similarly, list2 dot head, because you have to pass the starting address. Starting address is available in the head pointer. So control S F5. Now the node object has attribute print list. Here the print list, self dot head print underscore list you are passing, and you are passing self dot head as a parameter. So my list is passed as parameter here. List 3 linked list created. List3 dot head, list3 dot head, because it has to store the address. So you have to store here address, then you can write list3. Control S F5. Yeah. See, because the starting address should be stored in the head pointer. If head is not there, then it is in there. So now if you observe here, 10, 20, 30 first list, and 5, 15, 18, 35 second list. After merging, I got 5, 10, 15, 18, 20, 30, 35. So this is the way you have to merge it. Okay. So you must be very careful what type of address you are assigning. So here you have to assign to head pointer, because head pointer will be always holding the address. My list 3 is only the object. Inside the object, my head pointer is there. So head pointer will be holding the starting address. So finally you can display the list. So you must be very careful what type of pointer you are using and where you are storing the address. So this is the first list, this is the second list, and this is the merge list. So if you observe the merge list, all the data are coming in a sorted order. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.